Hello and welcome to another lecture of Chemistry Standard 12th chapter Solid State and topic is Defect. We know that in 1 mole constituents particles means 6.022 into 10 raised to 23 particles and there are 10 raised to 6 defects of particles. This value of defect may be negligible, but its effect on the structure and properties is observed. There are two types of defect, lattice defect. One, point defect. Second, line defect. First, point defect is due to irregularity around the atoms of crystalline substances. Second, the line defect. The line point defect is due to irregularity of the entire row of lattice points. These irregularities are called lattice points defect. There are three types of point defect. One, stoichiometric defect. Second, impurity defect. And third, non-stoichiometric defect. First, stoichiometric defect. It does not disturb stoichiometry of solid. It is called intrinsic or thermodynamic defect. It changes with temperature. There is also of two types. A, vacancy defect, and B, interstitial defect. Vacancy defect. Some of the sites of the lattice are vacant. There is a vacancy instead of particles. Such a crystal is called a crystal having vacancy defect. B, interstitial defect. When the particles get arranged in the interstitial defect, it is called that the crystal possesses interstitial defect. You can see in the figure. The defect increases the density of the substance because number of atoms for unit volume increases. See Frankel defect. The defect is shown in ionic solids. Frankel defect is observed in which there is large difference between the size of cations and anions. As for example, Zn(S), AgCl, AgBr, Agi. Cations displaces from original sites. This defect is also called dislocation defect. D, Schottky defect. This is the defect in the ionic solid. The number of cations and anions are not arranged in the crystal. This defect decreases the density of crystal. There are 10 raised 6 Schottky defect in 1 mole of NaCl crystal. There are 10 raised 22 ions in centimeter cube volume. There is One Schottky defect in can risk 16 ions in ionic solid like NaCl, KCl, AgBr shows Schottky defect. Impurity defect. Suppose SrCl2 is added into molten NaCl. Na plus ion occupied by Sr ion. Each Sr ion displaces to Na plus ion. It occupies one side and second side remain vacant. Another similar example is the solid solution of CdCl2 and AgCl. You can see the figure. Non-stoichiometric defect. There is no disturbance in the stoichiometry of elements, but constituent particles are in non-stoichiometric defect ratio. The first type of non-stoichiometric defect is metal axis defect due to the vacancy by anion means negative ion. Alkali halides like NaCl, KCl shows this type of defect. Suppose NaCl is heated with vapor of Na and Na deposits on the surface of the crystal. Cl minus ion diffuse in layer of the crystal and combines with Na atom and form NaCl. It is due to loss of electron in formation of Na ion from Na atom. Electron released from Na atom diffuse in the crystal and reach the site of the anion means negative ion. Because of this, there is increase of sodium in the crystal. The anion sites occupied by unpaired electron are called F centers. F means German word Farben center, indicating colored center. Crystal of NaCl possess yellow color. Axis metal defect due to presence of extra cations on the interstitial sites. When white color zinc oxide is heated, it becomes yellow because it loses oxygen. Zn plus 2 ion increases in the crystal, and so its formula will be Zn 1 plus XO. Metal deficiency defect. Another defect of non-stoichiometric defect, metal deficiency defect. It is very difficult to prepare solids according to their stoichiometry. They possess less number of metal atoms than calculated. As for example, FeO. FeO is in the form of FeO, where Fe is 0.95. In fact, it is in range of Fe 0.930 to Fe 0.960. In the crystal of FeO, some of Fe plus 2 ion are missing and the decrease in positive charge is satisfied by Fe plus 3 ions. Now another topic is conduction of electricity in metal, semiconductors and non-conductors. There are two types of band. One is valence band and another is conduction band. Conduction band means empty band and valence band means filled band. The space between two bands is called energy gap. If energy gap is less, electron can go to conduction band from valence band. If distance is more, electron from valence band are not able to go to conduction band. So conduction does not occur. This means this is called non-conductor. And non-metal or non-conductor. In semiconductor, 4 electrons in valence band are not free, so silicon does not conduct electricity. If temperature is increased or radiation are impinged, the electron of the valence band go to conduction band and conduction of electricity is occurs. Vacant place in valence band is occupied by other electrons of the substance. They become electrically conductor. So they are called semiconductors. Electrically conductors. The substance when electrically conductors are very less, i.e. 10 raised to minus 20 to 10 raised to minus 10 ohm raised to minus 1 meter minus 1. These are called non-conductor. Electrically conductors. The substance where electron conductance are in the range of 10 raised to 4 to 10 raised to 7 are called conductor. Electrically non-conductors. The solid substances whose electrically conductance are very less, means 10 raised to minus 20 to 10 raised to minus 10 are called electrically non-conductors, means insulators. Electrically semiconductors, the solid substance whose electrical conductance are in the range of 10 raised to minus 6 to 10 raised to 4 are called electrically semiconductors. In semiconductors, distance between band and conduction band are so it will conduct the less amount of electricity. The electrical conductivity increases with increase of temperature because electron jump from valence band to conduction band. Silicon and germanium shows this type of behavior, so they are called intrinsic semiconductors. Next topic is doping. If some impurities is added to it, its conductance can be increased. This process is called doping. N-type semiconductors. Silicon and germanium is doped with obtained semiconductor, which is called semiconductors of negative type or N-type. Next, P-type semiconductor. If boron, aluminum or gallium are doped with the silicon and germanium, there will be deficiency of electron. Such doped conductors are called positive type semiconductors, means P-type semiconductor. Next topics next time. Till then, goodbye.